Hello everyone and welcome back to my Trockers. So in today's lesson, we are working through a problem from the ZIMSEC November 2026 specimen paper 6082-1. This question combines standard integration with the trapezium rule, and that's a typical examination combination which all learners must know. All right, this was number 13, and the question reads, item A, find integral of e to the 3x sine 4x dx. Then B, the diagram shows part of the curve y equal to 1 plus x squared. The region R is bounded by the curve, the axis, and the line x equal to 1. Item 1, show that the volume of the solid formed when R is rotated completely about the x-axis is 28 pi over 15 cubic units. 2. Use the trapezium rule with 4 trapezia to estimate the area of R, giving your answer correct to 3 significant figures. Then 3. State with a reason whether the trapezium rule method overestimates or underestimates the area. Guys, let's go ahead and get started. All right, so 13 item A, right, 13 item A, we want to integrate e to the 3x sine 4x dx, right? So guys, we have that problem on the board, and remember when we solve this question using integration by parts, we apply the Layet rule with an assumption that we have one of the expressions that will become a constant after performing successive differentiations. But the case is different with this problem now. So we could solve this problem using the standard results or by repeated integration by parts. But I'm going to do the second method, which is repeated integration by parts, because we also want to revise on integration by parts, right? And it's more clear for me, right? So guys, we are going to see that after performing several steps or integrations, we are going to go back, or we are going to come back to the same expression, right? So what we could do here is to let, I just want you to follow, guys. We are going to let, right? Okay. So we are going to let I be equal to integral of e to the 3x sine 4x dx. So here we are not going to follow the Layet rule. Layet rule, it means anything on the left side must be differentiated. So like here I have the trig, I will differentiate the trig, I will integrate, but it doesn't matter whether I differentiate or I integrate, because none of these two will become a constant. So let me just say for this one, I will let u, right? So letting u equal to 3 e to the 3x. So if I differentiate here, right, I'm going to get 3 e to the 3x. Then my dv is equal to sine 4x, and when I integrate sine, I will get a negative cosine of 4x divided by 4, right? And we know that the integration by parts, right, is going to be integral. Okay, if I have a u dv, right, so if I have something of that sort, it is going to be uv minus integral of v du, right, sorry, minus integral of v du. So this is what I'm going to use, right? This is what we are going to use. So now I equal to uv, so it's negative 1 over 4 e to the 3x cosine of 4x, right, minus integral of v du, right. So allow me to take this negative and negative, it becomes positive 3 over 4, right. So it's now e to the 3x cosine of 4x, right, with respect to x, because it was now v, which is that, and so it's negative and another negative, it becomes positive over 4 here, then du, it is what, 3. So I just take out the constant. Then I'm going to repeat integration by parts again. So I will let my u equal to e to the 3x, and when I differentiate, I'll get 3e to the 3x. Then my dv is going to be cosine of 4x, and we know that if we integrate cos, you're going to get sine 4x over 4, right. So now I will have I equal to negative 1 over 4 e to the 3x cosine of 4x plus, remember I have 3 over 4, so it's now uv, so it's now 1 over 4 e to the 3x sine 4x minus integral of v du, so I'll take out 3 over 4, then I have e to the 3x sine 4x dx. But you know what, guys, from this stage here, this was I, and now we have the same integral, so I'm going to say I equal to negative 1 over 4 e to the 3x cosine of 4x plus, if I factor in, I have 3 over 16 e to the 3x sine 4x, this and that, it becomes minus 9 over 16 I. Then I'll take the I to the other side, so it's now 9 over 16 I plus I equal to negative 5 over 4 e to the 3x cosine, where did I get 5 from? All right, it's negative 1 over 4 cosine of 4x plus 3 over 16 e to the 3x sine 4x. So here 16 plus 9, that's 25, so 25 over 16 I equal to negative 1 over 4 e to the 3x cosine of 4x plus 3 over 16 e to the 3x sine of 4x. Then I will multiply both sides by 16 over 25, so I equal to 16, so it's now 16 over 25 minus 1 over 4 e to the 3x cosine of 4x plus 3 over 16 e to the 3x sine of 4x, right? Okay, so now I equal to, if I multiply here, it's now negative 4 over 25 e to the 3x cosine of 4x, then this and that cancels out, plus 3 over 25, 3 over 25 e to the 3x sine 4x, right? So therefore integral of e to the 3x, let me not forget the integration constant here, so e to the 3x right, sine 4x dx equal to, so I'm going to take out e to the 3x over 25. Then I'll have 3 sine 4x minus 4 cosine of 4x plus c. And we are done. Right. So that's all about this question, guys. Okay. So now we are moving on to B. This is number 13B. 13B. All right. Let me quickly put the diagram up here. Right. Okay. So we have this. Something like that. Something like that. Okay. It was a line. It was a continuous line. One. I have my R here. I have this. Okay. Interesting. I have 0. All right. So we were told that, or we are told that the equation is y equal to 1 plus x squared. All right. So we use that information when x is 1, y is 2. So here we know it is 2. So let me put 2. Then when x is 0, y is 1. I think we now have all the information that we need. All right, so the question reads, the diagram shows part of the curve y equal to 1 plus x squared. The region R is bounded by the curve, the axis, and the line x equal to 1, right? Show that the volume of the solid formed when R is rotated completely about the x-axis is 28 pi over 15. Then use the trapezium rule with 4 trapezia to estimate the area of R, giving your answer correct to 3 significant figures. Okay, so guys, that's what we have there for this problem. Okay. Sorry, I need this. All right, so on part 1, we need to show that the volume of the solid, formed here when this is rotated completely about the x-axis. So we have something like that. Right, so you want to find, right, this volume here, something of that sort. So this part, right, this is what you wanna show, that it's equal to 28 over 15, 28 pi over 15 cubic units. All right, let's go ahead and solve this out. So guys, we know that for this problem, we know that volume along the x-axis here is equal to pi integral of y squared dx with limits from x1 to x2. So here is going to be pi from 0 to 1. Right, so let's come back to the equation. So y equal to 1 plus x squared. So when it's now y squared, it's going to be 1 plus x squared squared. So here it's now 1 plus x squared squared with respect to x. Right, so it is pi, right, integral from 0 to 1. So it's first term, which is just 1, plus 2x squared plus x to the 4th with respect to x. Right, so we now have our pi. So here it's x plus 2x cubed over 3 plus x to the 5th over 5, right, from 0 to 1. All right, so upper limit minus lower limit. So here these are cubic units. So if you plug in 1, it's going to be 1 plus 2/3 plus 1 over 5, right? Subtracting 0. So it's going to be, if I say 1 plus 2/3 plus a fifth, right? I'm getting 28 over 15. So it's going to be 28 pi over 15 cubic units. And that's it for the volume part, item 1. So now let's move on to item 2. Item 2, it says use the trapezium rule with 4 trapezia to estimate the area of R, giving your answer correct to 3 significant figures. So guys, remember the trapezium rule. For the trapezium rule, we need to find the height or the intervals or the steps. So the height is always upper limit minus lower limit of a number of strips. And since it's already given in terms of trapezia, those are the number of strips. We don't need to subtract anything, right? So there are 4 trapezia, which indicates that we must have 5 ordinates, right? So let's start by finding the height. So it's going to be upper limit minus lower limit over number of strips. So the height is 1 over 4, right? But remember, our y is equal to 1 plus x squared, right? So we start by finding the x ordinate. So x naught is 0, right? So x1 is 0 plus that, it's 1 over 4. x2, it's 1 over 4 plus that, which is 2 over 4. Then x3 is 3 over 4. Then x4, it's 4 over 4, which is just 1, right? So we need our y naught, y1, y2, y3, and y4, right? So here y1, if we put 0, it's just 1. Here if we put 1 plus 1, that's 2. Okay, so now let's calculate. So if we say 1 plus 1 over 4 squared, I'm getting 17 over 16. 1 plus 1 over 2, 1 over 2 squared, I'm getting 5 over 4. Then 1 plus 1 plus 1 plus 3 over 4 squared, I'm getting 25 over 16, right? That's 25. So it's 25 over 16. Let me double check on 1/2. So 1 plus a half squared. Okay, I'm getting 5 over 4. So once we are here, just know that for the area, use this. It's always height over 2. So you just say first plus last plus twice the first, right? Which is equal to height over 2 of first plus last plus twice x2, x3, x1, x2, and x3. So x1, x1, x2, and x3, right? So which is, remember, height is a quarter divided by 2. So this was 1 plus 2 plus twice. I have, this is 17 over 16, 5 over 4. Okay, so I have 17 over 16 plus 5 over 4 plus 25 over 16. Right? Sorry, I need to double check something here. All right, it was 1 plus 3 over 4. Right? Okay, so now let's go ahead and simplify. So I'll solve this out. 1 over 4 divided by 1 over 4 divided by 2, open bracket, 1 plus 2 plus twice, 17 over 16 plus 5 over 4 plus 25 over 16, close. All right, close this or close that. All right, so I'm getting 43 over 32, which is equal to 1.34375. But remember, the question requires us to give the answer correct to 3 significant figures. So it is 1.34 to 3 significant figures. Right? Then, lastly, which is item 3. So B, item 3. State with a reason whether the trapezium rule overestimates or underestimates. But guys, remember this curve, and within the given interval, it concaves up or it is convex upwards. So once the curve is like this, right here, if we try to estimate the area using the trapezium rule, as you can see, there is also area that is being included here, the shaded part, which is not even part of the area. So therefore, since the curve concaves up or it is convex upwards, therefore it overestimates. It overestimates the area. So remember, guys, this diagram alone is a clear explanation. So include the diagram in that part. And also, if we come back to the original diagram here, we can actually see that this shaded part is included, but it's not even part of the area. So always bear in mind that when the graph concaves up, then it means it is going to overestimate the area, right? So guys, this specimen is just giving us a clear picture of the examination standard. Let's continue to practice on more specimen questions to get better and to prepare for the exam. I'll see you in the next segment. Take care.